So I want to thank Mrs. Maribeth Anderson for being here today. And I want to give her, I'd like to introduce Maribeth to the group. She is, as I said, Maribeth Anderson is the Director of Government Relations for Antero Resources. She came to Antero at the end of 2017 after serving in similar roles in Southwestern Energy and Chesapeake Energy since 2007. Prior to entering the energy sector, Maribeth was a consultant for Charles Ryan Associates and the news director for WSAZ Television. Maribeth is currently on the executive committee for the statewide West Virginia Chamber of Commerce and is a past board chair for the Huntington Regional Chamber of Commerce. She has served in industry leadership roles across 4 states, having been elected as the board president for the West Virginia Oil and Natural Gas Association. She is also the vice president of the Gas and Oil Association of West Virginia and on the board of the Ohio Oil and Gas Association, and in former roles served on the boards of the Kentucky Oil and Gas Association and the Virginia Oil and Gas Association. She is currently on the boards of the West Virginia Manufacturers Association and the West Virginia United Methodist Foundation. She's a graduate of Marshall, and I might add a Yeager Scholar. Maribeth earned degrees in journalism and economics. She lives in Huntington with her husband and has 2 children in college. Thank you, Maribeth, for being here. We're very fortunate to have you and thankful for your time this morning. So I'm going to turn it over to you.
Well, thank you for that. Thank you for the invitation to be here. And I'm glad you threw in the Yeager Scholar thing.
You were too modest.
I was in the second class of Yeager Scholars, and I don't know if people realize in Huntington, the people that live in Huntington now who would never have been here were it not for the Yeager Scholar Program. My husband is the CFO of the Marshall Foundation. He's from Cleveland. Had never heard of Marshall, but got that postcard in the mail to come and be a Yeager Scholar. The chief medical officer at Valley Health currently is Matt Weimer. He's from Toledo or some such, never would have come to Marshall were it not for the Yeager Scholar Program. These people came and stayed. Mike McCarthy's the chief technology officer at the med school. He was a Yeager Scholar, never would have come to Marshall, only just because, he just didn't know about it. So I'm really proud of that. I'm proud of the people who came to Huntington and stayed. I'm from Huntington. I might have gone to Marshall and been here anyway, who knows, right? But these people came from somewhere else and stayed. And so I like to say that every chance I get, because I think that has been and continues to be an important program at Marshall for recruiting people and people who stay. I mentioned this is kind of a daunting task for me to think about 90 minutes, so I'll need some help. And I've got John McKever's on the phone with me, who I'll introduce in a minute, and Greg Kazera, who you guys heard from earlier. And I'm going to have a third person help us with another point. But first, and I'm going to get to John quickly. He has to leave us at 11. Oh, can you give me screen sharing, Eric?
I thought you had it. You should have it.
Oh, I do have it. Sorry. Okay, y'all see that? Okay, before I get
10-4.
Okay. I want this to be more about the industry than about my company, but I do feel like you need to know where I'm coming from. So just 2 minutes about Antero Resources. And this is the only investor presentation slide that I'll show. Our investor presentation slides are really crowded, but it just shows that we're headquartered in Denver, about 200 employees in Denver and about 300 employees in Bridgeport, West Virginia. Our operating area there is in Ohio and in West Virginia. The shale, which we'll talk about, of course, is up in Pennsylvania as well, but Antero's in Ohio and West Virginia. And those 2 red triangles there represent the 2 rigs that we have running this morning, I believe in Tyler County. John will correct me if I'm wrong, but I believe we're in Tyler County this morning with drilling rigs. We're the 3rd largest gas producer in the country and the 2nd largest producer of natural gas liquids. And we'll talk about the difference there between natural gas and natural gas liquids. We're the big dog in West Virginia. In 2019, we produced 900,000 MCF. So, an M is 1,000, so 900,000, so 0.9 billion, almost 1 billion cubic feet of gas from Antero in 2019 out of West Virginia. The second largest producer is Southwestern, where I worked before, with 272,000 MCF of gas. So we're the largest producer in the state by a multiple. I'm going to talk about these things a little bit later when we don't have John, but I I'm going to introduce John now because he is our Vice President of completions for Antero. Completions is another word for hydraulic fracturing or fracking. He has worked all over the country as an engineer and a consultant in Texas and Wyoming and North Dakota and Colorado. And now, of course, he's over our operations here in West Virginia. Some of these advancements that you'll hear about, let me just start at the beginning and say that the natural gas industry in West Virginia is old, right? I mean, people say the first natural gas well in West Virginia was in Burning, the first natural gas well in the United States was in West Virginia in Burning Springs. So it's an old industry. So why all the hubbub now? Because in the 2000s, about 15 years ago, people figured out how to do two things. One is how to turn the drill bit sideways and drill horizontally. So horizontal drilling is the first advancement. The second thing is hydraulic fracturing. We always knew this shale layer was here. Think of the earth as like a layer cake with all these different geologic formations. And the shale is narrow. So we had to turn sideways to get into it. If you're just doing it vertically, you don't have enough pay zone. So we have to turn it vertically. And it's tight, meaning that the gas doesn't flow. So in addition to horizontal drilling, you need to hydraulically fracture that shale to allow it to flow. Those two things were pioneered in Texas in about 2001 to 2006. They kind of put those things together. And the Barnett Shale was the first shale gas development play. And then I think it went to Arkansas. John will have more of that history if you're interested in it. But in about 2007, it came to West Virginia. And hydraulic fracturing and horizontal drilling really changed everything. And we can look more at the production totals in West Virginia, which I'll do a little bit later, so you can see just how much it changed everything. You know, conventional production in West Virginia is now maybe less than 5% of the production. And when I say conventional, I mean that old vertical. Unconventional production is the horizontal drilling and the hydraulic fracturing. And unconventional production, which has just come online since about 2007 or 8, is now 95% of all of the gas production in West Virginia. So I thought we'd bring John in to talk more in depth about those things and ask questions and interrupt if you want to. I'll say that there's very uneven knowledge in this state about natural gas. I never, those last 5 minutes that I did, never would have done that in Wheeling or Clarksburg, right? They're used to this, they live with it, they see it. But in Huntington, I don't know that we know that much about the shale gas drilling. So that's why I'll say that feel free to interrupt John. He's a fabulous teacher. But as we go through this, I'm just going to kind of ask him some questions and lead him in discussion with us for about the next 15 minutes. So John, I gave a very rudimentary explanation of horizontal drilling. Will you add more into that in terms of, does it all happen with one pipe, and how does the pipe make the turn? And, you know, how do they protect the groundwater and all that stuff? Why don't you tell us a little bit about that?
Yeah, no, if you want to get the, you had a PowerPoint presentation. If you want to put that up again, share that.
Sure.
We could go through bits and pieces of that, but yeah, thank you for inviting me and giving an opportunity to visit with everybody. And you know, your curiosity is fantastic, because that's probably one of the biggest, I won't say failures, but as far as us as an industry, oil and gas, it's used by everyone every day, but yet most Americans aren't privy to what it actually is, what it takes to get it out of the ground. And just take a step back a little bit. You know, we talk about oil and gas, we say that word together synonymously. But oil is, you know, as far as how much oil we produce, about 11 million barrels of oil a day in the United States. We have to import quite a bit because our consumption is higher than that. But natural gas is domestic. It's produced domestically. It's used domestically, and now we're able to export it. We import very little gas. We import from Canada just because of the geographical location of the upper Northeast. That's really the only place we import. But domestically, the United States drives its own gas price by how well we're able to drill for gas, produce it, get it in the pipelines, and then of course storage. So I won't get into the storage piece, but that's a big chunk of it too, is having the storage, the availability to store gas in the summer when we don't need it. So in the wintertime, we can pull it out and utilize that gas on demand. So we have it available. But Greg will talk about it a little bit, but in 2010, which is not very long ago, we were probably 55, maybe 60 billion cubic feet of gas a day is what we produced. And now we're up to about 91, 92 billion cubic feet a day domestically is in the U.S. And the triangle, or Pennsylvania, Ohio, West Virginia, the Marcellus, Utica shales generate or produce about 34 billion cubic feet a day. So over 1/3 of all the natural gas production comes out of this, I don't know if I could overgeneralize, by 500 by 500 square mile area, which is a big area, but when you think about the volume of gas that's produced, it's pretty phenomenal. But Greg will get into that, have more time. But on the drilling piece, so here's a typical drilling location, and at Antero, what we really focus on doing is we focus on building on the highest elevations for multiple reasons, but we don't build down. We don't build our locations. This is called a pad. We wouldn't build a pad down on the low spot, down by water, down by rivers, down by creeks. We don't do that. We build it up on top for various reasons, safety really being the biggest one, and then the roads, building the roads up there. But this is what a typical drilling location looks like. And yeah, as far as the pipe, it's all to overgeneralize, but each joint of drill pipe. So a joint is a piece of drill pipe, just like a 8-foot piece of lumber is 8-foot piece of lumber is when you're building a house, a single joint of drill pipe is 30 feet, and it's steel, and then so it's multiple joints, but it's not one continuous piece of pipe. It's made up, torqued to a very high foot-pound specification, and we just pick it up and drill in the hole. And really, if you want to jump to the next slide, as far as slide 7. So you kind of say, well, how do we directionally drill? How do you know if we drill a 15,000 foot lateral? So if we go sideways 3 miles, again, it's 15,600 feet, 700 feet but to overgeneralize. So 15,000 feet, 3 miles. How do you know where you're at 3 miles away from where you started? And it all has to do with what all comes back to magnetics. So it's directional drilling. It's using magnetics, very similar to a compass, but of course, very advanced, because those magnetics, accelerometers, magnetometers, they're under extreme shock, because you're drilling at high pressures, high vibrations. So those sensors are very durable. But really, what it is, you're looking at the field strength of the magnetic field on the Earth, the declination angle. You guys are familiar with magnetic declination. West Virginia, some parts of West Virginia have a severe magnetic declination, meaning where's true north from magnetic north. There's a difference there. You got to know what that is, and then the dip angle. So all these components I talk about, they're all used for more QC. Similar to so quality control. Because what you're really trying to get to, what these tools measure, is they measure inclination. So are you at 0 degrees, which is straight up and down, or are you at 90 degrees? So that's inclination. And then azimuth is just very similar to a compass. Are you north? Are you east? So north is 0, east is 90, south is 180, west is 270. Just think of a 360-degree circle. That's the azimuth. And then tool face is a little bit more in depth, but that's how you're basically able to turn the bit to go different directions. But steel, it's hard to imagine. Well, how does steel bend? Well, steel does bend over a large radius. So we're building these curves from 0 to 90. We're building that in about 1,000 feet. So it's a long gradual curve, and that steel bends, and it's able to torque, and it's able to go through that curve without too much of an issue or too much of a problem. Yes, just like any industry, any business, there's always problems, there's always failures, but that's what we have engineers for, is to calculate that, figure out how to make sure that those bending moments aren't too much. But that's kind of an overgeneralization of just some of the background on directional drilling. It's accelerometers, it's magnetometers, it's knowing. So when the rig sits there at surface, it's knowing exactly the magnetics of where we are at that exact point, at that exact 1 foot by 1 foot. We know exactly what the magnetics are. So then we can continue calculating the magnetics, 15,000 feet away. You have to know where you're starting to know where you want to finish up. And I think that's pretty common in life too, is you have to know where you're starting. So we can go to the next slide. And then again, this is, yeah, I think he went up on that one.
Oh, is this where we are?
Oh, sorry, that's my fault. I'm toggling through a couple of things. There we go. And again, this is just overgeneralizing, but gives you an idea, geographic North Pole, the rotation of the axis. I mean, it's very complicated, but it's very simple. It's things that we've used for, years and years and years. You think about captains on ships 300 years ago, and these are very similar components. But again, we're looking at, and then also when you're talking about magnetics, we're talking about basically all the magnetics are known across the entire world, and it's put on a chart, put in a graph. So you can put in your latitude, longitude, exactly what your magnetics are. So we have a couple different models here. I won't really go into them, but really what we use is this model called HDGM, and that's a high res model, and it's updated annually. Just you guys know that the North Pole is where North points does change every year. It's not north today is different than North was 25 years ago. So those models get updated. So we're constantly using the most updated models to make sure that we're staying up to speed with where we're at, technology, things of that nature. So again, this is just another representation. So you can go to the next one, and these are actually the tools. And what's amazing to think about this. So there's 3 magnetometers, 3 accelerometers. I'm probably getting into this too much, but really what they are is they're in a 3-axis X, Y, and Z. So as that tool turns, you've always got 3 axes X, Y, and Z. So think of 3D, and that's what we're working with. Is it's not just one measurement. It's all different. It's 3D.
So this tool is what's on the end of the drill bit, right?
It's right above the drill bit. That's right. The drill bit's the very end. So this is right behind the drill bit. You're exactly right. So it's right where we're drilling. So
and so we
and
go
then what's even yep, go ahead, Maribeth.
a mile down, right? The Marcellus Shale's a mile underground.
6,500 feet, 1.25 miles maybe. Yep.
Okay. And then it goes, and then it makes the turn and can go out, another 2.5 miles.
Yep. And then we want to land that in an exact zone, so we know exactly where that depth is. And when we turn that, we also have measurements that can measure the rock, like as far as what kind of rock we're drilling in, because we have to know what we're drilling. Depth is one thing, but we have to have an idea of what the rock looks like. So yeah, we make that turn, and then we just continue staying in zone and drill that lateral, and that's exactly right.
Mm-hmm. Let's see. Do you want to talk about?
And then this is in Colorado. This is the DJ. This is the reason I bring this up, one, because I had an example. But it's called the DJ. It stands for Denver Julesburg Basin. Greg can correct me if I'm wrong on that, but it's been quite a while since I've worked in that area. But this is looking at the very end of the wells, looking back, and then as they go up, that's the vertical. So this is looking at the end of the wells, but it just shows how we have to drill these laterals. And what this is a good representation of is these laterals aren't all on the same plane. You have one up here, one down there, and one over here, but it's all drilled off the same pad. So that's the other thing that's really made it significant in the state of West Virginia. It's a beautiful mountainous state, so the terrain is very rugged, very, very challenging. So if we can reduce our footprint, our pad size, or if we can reduce our footprint by drilling more wells from a single pad, it's obviously less locations we have to build and less facilities, you name it. But this is exactly how we're doing, is drilling. This particular pad has 8 wells sitting on it. So this shows the end of the wells, and you're actually looking back at the end of the well, and then now, of course, this is, I say looking back at it, this is computer generated, but this is the information that we get kicked out and that we're looking at as engineers. Let's see.
Spiders.
Yeah, so this is called a spider plot. So this is a single pad that right in the middle there, all those numbers, that's a pad we're drilling from. So this one we drilled 1, 2, 3, 4, 5, 6, 7, 8. Looks like we drilled 8 or 9 wells off this pad. And this is just the vertical sections, and you can see the curves being built, and then for instance, I don't know if you can see this, but yeah, these wells, like as far as this yellow one on the left, that one's going to the northwest, and then this brown one on the far, or purple one on the far left, that's going, kind of southeast. Yeah, way over to the left, and then so this is again just the vertical portion, steering these wells, and then landing them in zone, and then kicking off and drilling the laterals. But this gives you an idea of they all start in the same spot, and we're getting our separation, and we're drilling these wells from one spot, and we're targeting multiple. We're targeting the same zone, but we're targeting multiple horizons within that same zone. So that's what we're able to do here. And on the drilling side, yep, go ahead.
Well, I just wanted to toot your horn a little bit because you might not do it, but Antero keeps breaking records. It's just a note of the evolution and the technology, the way it advances. I mean, 12,000 feet in a day to drill, 2 miles in a day. And what, in 2007, how many feet could we drill in a day?
2,500.
Yeah. It's just amazing.
2,000 maybe.
This technology keeps advancing.
So that's an overgeneralization, but it gives folks an idea of, well, how do you do that? How do you drill horizontally? And that's you now know probably more than 95% of the U.S. population, more than you wanted to. But and then this is the same pad, but the drilling rigs moved off, and this is the completions phase. So we've got you can see our water tank back there on the kind of right smack in the middle of the picture. Yep, there's our water tank. That's what we'd use for water. And then you've got just to the straight down from that, you've got these not upright, but kind of at a slant. That's where our sand is. We store our sand in that, and that's what delivers the sand, so we can pump it. And these are all the frac trucks that are, we call them frac trucks. They're high pressure pump trucks. So roughly we're pumping about 85 barrels a minute. So a barrel is 42 gallons, so it's not a barrel like you think of 55 gallons or 50-gallon drum. Standard barrel of oil, standard barrel of water in the oil field is 42 gallons. So we're pumping about 80 barrels a minute. So a significant amount of volume down into this rock. And this is all cased. So after the well is drilled, then we'll pull out the drill pipe, and then we'll actually run in a permanent steel pipe that will go all the way to TD. And then we pump cement around that pipe to completely isolate all the formations, and then also up above, where the water, coal, salt water is. We've got multiple different casing strings in the vertical that protect all the surface water. Down to roughly 2,500 feet, we've got 2 or 3 casing strings that are protecting all the groundwater. And that's one thing we do too. Before we go out and do any work and drill within, let's say, like 1,000-foot radius, which is pretty significant when you think that's a 2,000-foot diameter, it's almost half a mile. We'll go out and test all the water wells because we want to have a baseline. What does that water look like, prior? And we've not, from hydraulic fracturing, we have not had any instances of fracking into someone's water well, destroying someone's water. Now, I mean, the oil and gas is just like any other industry, like the banking, the banking industry. You've got your bad actors and your good actors, right? So not every company does things perfectly, but we're all lumped into the same category. So yes, in the past, not in West Virginia necessarily, but yes, in the past, some operators could have done things poorly and not to the standard that they should, which is the standard we hold up to, and a very high standard of how we what's called well construction, how we drill our wells, but again, every industry has the bad actors, and oil and gas is no different. Unfortunately, everyone gets lumped into the same, the same group, so to speak. But anyway, this is what a hydraulic fracturing pad location would look like.
Mm-hmm.
And we're pumping 99.5% water and sand, and we have a little bit of chemicals. It's called FR, friction reducer. So it's just something that as we're pumping at those rates, it keeps the pressure down, and it's just like it's a plant-based friction reducer is what it is. And to say it as plainly as it is, that's all it's for, is just to reduce that friction. So that's pretty much what we're pumping down hole. And then all the chemicals that we would pump, they have to be reported federally, statewide, federally. So it's all out there, what's injected. But again, you're thinking, a 1.25 miles down hole. That's pretty deep. It's taken 2 million years of overall evolution just to build up. You think about geologically, 6,000 feet of rock. So there's very little chance. There's no chance to hydraulically frack into the Marcellus and grow up, fracture up to, let's say, 1,000 feet. It's impossible. You think about the overburden, the strength of the rocks, it's impossible.
Yeah.
But anyways, just give you an idea what a frac site would look like.
Certainly a big operation, lots of trucks, lots of sand, lots of water. Then
Yep.
it moves off, and you're left with kind of this big parking lot kind of a thing with tanks for water and condensate, and then the Christmas trees. Do I have another picture of that? No. John, I'm worried about your 11 o'clock. I'm going to let you go.
Yep.
And
Yep. As far as you and Greg could talk about that, kind of where we're at, natural gas, I touched on it. The big driver for us is LNG, liquefied natural gas. Maribeth talked about NGLs, and that's natural gas liquids. So that's your butanes, propanes, isobutanes. Those are natural gas liquids. Now, and then LNG is where where a company will cryogenically, so they'll freeze it just like liquid nitrogen. You guys have dealt with liquid nitrogen before, seen it, and that's what LNG is. We're actually freezing those gas molecules to a liquid, putting them on a ship, and then transporting them to Asia, Germany, generally Europe, and that way they can have natural gas where they previously couldn't have it because they didn't have natural gas, and to try to transport natural gas in a gaseous phase it's just uneconomic because it takes up a large room. Well, when you cryolly freeze that, now you get that huge volume into a very small piece, and now you can get much more volume on a ship. So it comes down to economics, but sorry, I apologize for being brief this morning. Gave you guys guys and gals a little bit of a introduction. Greg, good to see you again. It's been a few years. You look younger now than you did 4 years ago. So you look good.
I'll accept that. Thank you.
before you go, John,
Maribeth.
I'm going to let you go, but I think we have one question.
Yes.
Is Rick there? I think he's got a question I saw in the chat. Is it for John or for me?
Either. Two quick questions. One's very simple. Does every horizontal part have to have its own vertical, or can a single vertical share two horizontals? The second question you could, if you wish, can answer. In the old days, we talked about having owned land, and you had timber rights and oil rights and gas rights. Well, now that you can go horizontally, how do you attribute how much gas you got from one person's land versus another?
Yep. No, I can. Back in North Dakota, I worked for Hess, large corporation, and we did what's called multiple laterals. So we did one vertical well bore, and we do two horizontals out of that. It's very complicated. It can be done. It's done offshore all the time because offshore you're even more limited on space, right? So, but on land we've done that. We don't do it right now in the Marcellus or the Utica, but you certainly could drill two laterals from the same vertical. It is a little bit more challenging. You have the potential of You know, thinking about flow, and it kind of works into the second question you asked. You're absolutely right, but you can. It's called multiple laterals. It's not done in the Marcellus or Utica, but it is done in the Bach and other areas. And then you're right. So talking about horizontal, so that's probably the biggest challenge we have, is just getting our land piece put together. Before we can drill a well, we have to identify every tract of land that we're going to be drilling in subsurface. So, and obviously West Virginia is an extremely old state, historically, when I say old as far as land ownership. So multiple heirs, right? So if someone owned that land in 1825, it's been, you know, handed down to brothers and sisters and their kids, and trying to find all that heirship is extremely complicated. So what we do is simply put, if one horizontal takes up 100 acres of land, then we identify all the people in that 100 acres of land of minerals. If you own 10 acres, you get 10%. It's as plain as that. It's as simple as that. If you own 5 acres, you get 5%. So that's how the minerals are split up. That's how the revenue is split up to the mineral owner, not the surface owner, the mineral owner. Because sometimes that's called what we call a split estate. The surface owner is the surface owner. If they don't own the minerals, that's called a split estate. That means someone had sold off the mineral rights years before.
Yeah. Thank you, John. I'm going to build a little bit more on that point. I appreciate you.
Yep. Thank you, everybody.
Okay.
Bye.
To change one thing about oil and gas development in West Virginia, if I had a magic wand, it would be this: to solve and fix this question of divided estates. And of course, there's no way to do it. People sold off their mineral. In Pennsylvania, it's not a problem. If people own their mineral, they own their surface. I don't know if that was because of a law or just was not custom in northern Pennsylvania, especially. There just are not divided estates. But here we have this problem where people sold off their mineral. So people live on the surface and they get to deal with all that traffic and all that noise and all that dust, and they don't get the benefit of the mineral royalty. And if I could change one thing, that's what it would be. And of course, companies there are surface use payments, and there are other things that we do in the community to try to mitigate that. But it would be so much better if people who own their surface also own their mineral, but it is what it is. Where do I want to go next? I will say that Elizabeth asked me to do this, and I was happy to do it after I got over the 90 minutes piece. But I'm an advocate for oil and gas. That is what I do. That's who I am. And so she brought me there under that, with that hat on. But I'll also say that I'm a journalist in my bones. All my years at WSAZ with Eric have made me kind of a journalist in my bones. So I will try to kind of play this down the middle. But one thing that I do want everyone to know is this particular tax that we pay, because it has to do with education, and I know you guys care about that. Property taxes from oil and gas. I could talk about severance taxes. I could talk about sales taxes. I could talk about income taxes, but this is just the property taxes that we pay on the value of the hydrocarbon in the ground in the wells that we own. We've drilled 1,000 wells in West Virginia since 2008, 9 maybe. So this is more about this point that we've been making about conventional or vertical old well production, right? That's what's in Cabell County and Wayne County, old vertical conventional wells. So from a property tax perspective, operators paid the Cabell County Commission $103,000 in 2020, and the Wayne County Commission got $500,000. Doddridge County got $31 million in 2020 alone. Tyler County got $32 million in 2020 alone. These are rural counties with tens of millions of dollars in 1 year alone. So what does that mean? By law, they have to give 70% of it to the schools. So per pupil spending statewide is $12,000. In Doddridge County, per pupil spending is $20,000. And that is translating to this morning, they are putting up fiber so that every school-age child in Doddridge County is going to have high-speed broadband. The Board of Education is pitching in more than $1 million. They got a grant. Doddridge County got a grant, I think, to do, kind of wireless there in West Union. But then that last mile, right, that last bit of fiber, that's being paid for by the Board of Education because they've already done their AstroTurf. They've already done they have an indoor pole vaulting pit at Doddridge County High School. In Wetzel County, another rural county where the county commission has tens of millions of dollars, air ambulance service there is free. I think that's just something that they thought they could do to help their residents there because it's a rural county and maybe not easy access to the hospital. So if you need air ambulance in Wetzel County, the county commission picks up the tab. So just two observations about the benefits of oil and gas that really just, they don't get talked about enough. So I just kind of wanted to make that point. I know that Jason is here with us, which is our second guest that we're going to talk about, but I wanted to kind of, before I transition to Jason, who's going to talk with us about some safety issues that I just think are really interesting. I wanted to talk about the number of horizontal wells reporting production. And when we talk about a revolution, a shale revolution, it is truly that. So in 2008, there were 168 wells, horizontal wells. And now in 2018, you've got 2,900, almost 3,000 wells. And so the gas production in West Virginia has gone from 259,000 MCF to 1.7 million MCF, which is 1.7 trillion cubic feet of gas from West Virginia. That is the increase in gas production that has happened all because of horizontal drilling and hydraulic fracturing. I know that the 2019 number is over 2 trillion, 2.1 trillion cubic feet of gas. And no sign of it going down because even when the rig count goes down, those laterals keep getting longer and keep getting longer. So annual production from horizontal wells in 2008 was just a little bit, what's that say, 6 million? And now it's 1.6 TCF, 1.6 trillion cubic feet just from horizontal wells. And so what's the percentage of total gas production in the state from horizontal? You know, the old conventional wells are now just 7% of the production in the state. 93% of the production in the state is from horizontal wells. In 2008, 98% of the production in the state was from those conventional vertical wells. Number of conventional wells, you know, it's kind of gone up and down, right? But leveled off here at 60,000 vertical wells in the state. But the number, I guess I didn't put the number of unconventional wells, but there are, I know Antero has 1,020 conventional wells. There's probably 5,000, I'm sorry, unconventional. There's probably 5,000 unconventional wells in the state as opposed to 60,000 vertical wells. But those 5,000 have 98% of the production. Just goes to show how much more productive they are than the old vertical conventional wells. And from a land use perspective too, you know, you've seen the old pictures of kind of where the pin cushion, right, with all of the rigs lined up right next to each other. But because we are able to drill down a mile and then drill out 2 or 3 miles in all these different directions, kind of like a double pitchfork. You saw those spiders. The land use is much less because of this production. Jason, are you with us? I think you are. You need to turn off your mute if you're muted.
I sure am. Can you hear me?
I can.
Great. I'm going to try my video. Let's see if this works out okay. You know,
There you
bandwidth.
are. Yeah.
Hey there.
Hi. Jason works with us in Bridgeport. He was the first person that I met at Antero, other than my boss, of course. And he's worked with us for 10 years, not that long.
Yeah, no, longer, 11.
Okay.
So I, celebrated my 11th year almost a month ago exactly.
So he's there in Bridgeport and was one of our first employees in West Virginia. Is that right, Jason?
That's right. Yeah.
Yeah. And one of the things that has surprised me and interested me since I moved from television news to oil and gas was this emphasis on safety. And just the way that it's achieved has been interesting to me. So, I mean, I I would put out there that this can be dangerous work. I mean, you're dealing with hydrocarbons that are under pressure. And certainly this emphasis on safety has evolved. We talked about kind of the old pictures of the vertical wells lined up, you know, all over the landscape. But I've also seen old pictures that just make me cringe of, you know, children on sites, old, no personal protective gear. We're so indoctrinated now with the hard hats and the flame resistant gear and that kind of thing. And you look at these old pictures and they're just make you cringe. Tell me how you've seen, Jason, kind of this safety notion evolve over the years.
Yeah, no, absolutely. And, you know, before I get into that, you know, thanks for having me today. You know, really appreciate speaking. And if you guys can solve that estate heir issue, I have a personal family farm that I could benefit from a little bit there. But yeah, so back to your question, you know, any industry or any occupation has some element of risk that has to be considered. And, you know, in oil and gas is certainly no different. You know, the way that you handle that is you identify the risk in the workplace, and you know you do that using a number of tools. Once the risk is identified, you try to eliminate it, and that's your goal. Your goal is to eliminate the hazards that are present, and you know once they're eliminated, then they don't pose a threat to persons working on that site. If elimination isn't possible, then you have to undertake the task of managing it, and that's that becomes the challenge that we're all faced with is managing the remaining risk. You manage that through engineering, design, procedures, personal protective equipment, as you mentioned, and over the past decade, my experience here in oil and gas, technology is the change factor. We've heard John. I listen to John. Every time I listen to him, he tells me something I didn't know before. And John talked a lot about technology and how it improves efficiencies and make things faster, more efficient. They also make things safer. For considerations, when you take that safety, one of the big advances is the distancing of workers from the hazard. So you take that technology, you add in what we refer to as iron roughnecks, tubing handlers, hydraulic catwalks, top drive units, and those are all Googleable items. You can just Google those terms and you'll find pictures. But what they do is they distance a worker, their physical hands from the hazard, from the pinch points that caught in between the struck by hazards, and they allow the worker to work safely, and they also help standardize and automate those processes.
Mm-hmm. Mm-hmm.
Work has to be done under a procedure or under a process, and for us in oil and gas, we use the term job safety analysis, or JSA. A lot of people refer to them, and those JSAs they outline the step-by-step process, beginning to end, that is to be undertaken. And part of that analysis includes an identification and a mitigation of those hazards. So, we don't commence work without, really fully understanding what's going to be undertaken, what has to be done, equipment needed, processes utilized, and controls in place. And that takes a lot of effort. That's a lot of management effort, a lot of participation effort, and a lot of diligence. But, all of that kind of leads to our final layer of protection, or our final barrier. And you mentioned it a minute ago, the personal protective equipment. Advances in personal protective equipment are just every year, every month, there's new products, there's new technology. When I started 11 years ago, fire-resistant garments. They were not standard, they were recommended, but they were not required. Today, you cannot work on an oil and gas location without fire-resistant garments. Of course, hard hats have been a standard, but even technology and hard hats have improved vastly. And, ensuring that hand, eye, foot protection, just to name a few, are all in place, meeting ANSI standards and requirements. That takes a lot of diligence and a lot of effort on that location.
I'm interested in the psychology of building a culture. It has been very interesting to me to see how you guys get employees to own it. Some people have on their sign off, it has their name and their phone number, and then it says disagreement does not mean disrespect. And you encourage disagreement. You encourage people to stop work if they believe they see a hazard. Talk to me more about how you build that culture at an oil and gas company.
Oh yeah, it's not easy. Culture in any way is difficult to build. What it begins with is understanding responsibilities. Safety. If you watch the news or watch, especially advertisements, there's not a product that isn't advertised with the word safety. So safety is a responsibility of everyone, and it's inherent in everything that we have and everything that we do. But for oil and gas, it's not just those that are at risk, not just those that are on a well site. Safety is the responsibility of the whole company, of every member from executives down. And to create an effective safety culture, you first have to set the expectation. And that sounds overly simplistic, and I'm sure everyone's like, well, duh, of course, that's where you start. But safety performance should be included in any other performance metric that a company has. Whether it be an efficiency metric or an economical metric, the safety metrics should be in there just as well. And it really needs to be a part of how you do business. It's one of those, what you inspect, is what you expect kind of item. So keeping that at the forefront is important. And, integrating safety culture into a company, it begins with planning and design and process. You as a company, you can't undertake a project, a task, a development of a single well, of a basin of wells. You can't do that without considering impacts and hazards and making appropriate planning. And it just makes for a more efficient, more thorough process. That process is commonly referred to as a management of change process that's undertaken to ensure that anytime we undertake a new project or go out and do a new well or a new activity, that we manage that change in the organization thoroughly. And kind of a final area that I would say is necessary for a positive safety culture is stop work authority. Stop work authority is it's a common term that we use in oil and gas, but you'll see it in many other industries as well. And stop work authority, simply put, is the ability for anyone to stop or slow work that they observe or feel is at risk, like an at-risk behavior, which would be, someone doing a procedure incorrectly or something unsafe, or an unsafe condition. And an unsafe condition might be, ice on the walkway, just as an example of an unsafe condition. So with that stop work authority, that's where management has empowered everyone to issue that stop work, and to do so in an environment that, and this is the critical component, that is free of negative repercussions. No one can get in trouble. there's not going to be any retaliation. You're not going to be demoted or anything like that if you express a concern. And that kind of fundamental underlying for a positive safety culture where everyone feels that they have not only the right or the authority, but the ability to speak up and express concern in an open environment. So I think that's important.
I'm going to move on to Greg, but I do have one more question for you if you can answer it quickly. This hour's gone fast. What does success look like? I mean, is it possible to say we expect 0 incidents, that we're not going to have any accidents? I mean, accidents are accidents. They're not, you don't plan on them. But so what does success look like?
No, absolutely. I think 0 incidents is completely achievable. Success can be difficult to define because, from a general standpoint, you have to consider all factors for success. Is it done safely? Is it done efficiently, economically? Were the meets and the objectives? But from a safety viewpoint, establishing criteria to measure safety performance. That's what safety professionals do, and we use a combination of what we refer to as leading and lagging indicators. Leading indicators are kind of what you would expect. It's audits and evaluations of the workplace, of the contractors or workers performing the work. It's also training of employees, evaluation of the effectiveness of the training of those employees. We also trend and analyze what we call BBS observations, behavioral-based safety observations, and these BBS observations, commonly called stop cards, are where workers can anonymously sometimes or put their name to it, observe a positive or negative behavior and either find an area for improvement or a good success, a good win. And looking at all those near miss events that occur, and all those help us build a framework to apply resources to achieve that 0 incident goal. Some of the lagging indicators, just real quickly, OSHA and the insurance industry, they provide us with some of the great lagging indicators, and these are ones that you've probably heard. Indicators such as a lost time incident rate, very, very commonly used, total recordable incident rate. Again, these are defined by OSHA. One that isn't as commonly known but is still very effective is the experience modification rate, and that's an insurance industry rate. And those are indicators of performance. They really help to show us the level or the potential risk that work or contractors can pose. But all of those go together. Using the Bureau of Labor Statistics and other benchmarking services to really drive in and focus and allow that top-down management approach where we apply, focused resources and most importantly, accountability to ensure safety. Great.
Well, thank you, Jason, for that. I appreciate you helping me explain some of these safety, how oil and gas companies approach this the most important topic, which is, of course, worker safety. So feel free to linger and listen to Greg for a few minutes if you want to.
Oh, great. Yeah. Hi, Greg. Good to see you
again, Jason.
Yeah.
Good stuff. You haven't changed much at all.
Oh, I appreciate that. I feel like the pandemic's been difficult for me.
So I think it's been difficult for everybody.
Greg Kazera, he's going to help us talk about the future of this industry. And it's all about the natural gas liquids. We've talked a lot about this mixed up stream of hydrocarbons that comes out of a well. It's, we have to put the land together. We drill the mile-long hole. We go out a mile or 2 or 3. We suck the hydrocarbons up, and then they have to be processed and separated. The largest processing plant in North America is in Doddridge County. The largest gas processing plant in North America is in Doddridge County. It's called Sherwood. Mark West, Marathon owns it. Antero is their sole supplier. And that's where you get the methane, the propane, the butane, the propane, all of it separates out and then goes to their markets when it comes out the tailgate of the processing plant. And Greg is so articulate in talking about why those liquids are so important. And he's let me introduce him more specifically, the Director of Marketing for Shale Crescent, regional nonprofit research and economic development marketing organization. He's a professional engineer, and he is got his master's in environmental engineering from Marshall University. So, Greg, I'm going to turn on these slides and let you have at it.
Okay, fantastic. Hey, appreciate the opportunity to visit with everybody. And, Maribeth mentioned Sherwood. I'm also an adjunct professor at Pierpont, and my students are working at Sherwood. And those are, when you think about a student, these students were all working other jobs. They didn't just go to school part-time. They actually were working, but probably making 20, 25 grand a year. And all of a sudden they graduate from Pierpont and get to go to a place like Sherwood, and they're making 60,000 plus. And what an opportunity. I asked our students, what are you going to do with that money? I mean, all of a sudden you've got these paychecks, and folks, here's the three things they're going to use that money for. And they're already doing this. Is first, they're going to buy a pickup truck. I mean, this is West Virginia. So these guys in particular, they know what that truck looks like. I mean, they can picture it. Second is a home. And what that means is we got people that are living in West Virginia, young people that are staying here, that are raising families here now. And the third one, since again, we're talking about Pierpont and Fairmont area, WVU season football tickets. So those are the three things that they're going to do with their money. But that's the whole point, is bring in jobs here. And that's really what I wanted to focus on, is that whole process is, this is great. We got these liquids, we got the gas, but what are we going to do with it? And in this presentation that you're going to see today, actually, Joe Eddy and I are going to, we're going to be doing it tomorrow for Plastics News. They do a noon live stream, and Joe's the retired CEO of Eagle Manufacturing up there in Wellsburg, West Virginia. So really we want to talk about that, and just so you know who and what Shale Crescent USA is. We're a nonprofit, and our whole goal is to take advantage of these liquids that Maribeth and John were talking about, and turn those into jobs. And our message tomorrow is to primarily plastics processors. And what we're going to explain to them is why you should expand if you're already here. And if you're not here, why you should come here and start to create jobs. So we'll kind of share some of that stuff. And
Greg, just tell me when to advance the slides and I'll do it.
Okay. By the way, so what we call the Shale Crescent USA region is West Virginia, Ohio, Pennsylvania. As a nonprofit, we're founded by a group of business and community leaders in the Parkersburg, Marietta area. And their whole mindset was, folks, is nobody knows. We've got this great resource, and we've been doing manufacturing since the 1800s. And we're all of a sudden, we're this rust belt, and nobody really knows about us. And we had the tri-state group that the three states, West Virginia, Pennsylvania, got together, and we weren't seeing that go at the speed of business. We wanted to see this stuff start to happen. So what we do, we do research and we do marketing, and we're working regionally. So the numbers that I'm going to show you are really regional numbers. And we felt like the two brands that were out there about this region, Appalachia and Northeast, neither one of those are very positive nomenclatures. I was in Tokyo probably 3 years ago now. And if you talk about the Northeast, everybody thinks about New York City and Boston. Well, we don't want to be associated with that. And of course, John did a great job of talking about the technology. And can you imagine being able to drill down 10,000 feet and out 12,000? I'll tell you, I left the industry. I retired in 2016. So I've been doing this economic development for 5 years. But after 40 years in the oil and gas industry, it is shocking how fast that technology moves. I mean, just in 16, I think the longest lateral was about 14,000 feet. And now you guys are up 3 miles underground, down 10, out 3, and doing it. The numbers I'm hearing, Maribeth, were like 15 days. I mean, it used to take us, when this thing started in 2008, I was in the industry working for a service company. It was a month and a half to get 3,500 feet. And so that's the efficiency. That's what we've got. So what are we going to do with this stuff? And go ahead and advance it now, Mary. Next slide, please. We've all been through the pandemic, and we learned a lot. And one of the shocking things that all Americans learned is suddenly New York State didn't have ventilators. They were waiting on planes from China for ventilators. We didn't have, try to find sanitation wipes, try to find hand sanitizer, try to find these folks are wearing garbage bags because they didn't have PPE. We weren't making that stuff. Gloves, personal protective equipment, things like gowns, face shields, all those were being imported into the country. And suddenly Americans were like, wow, we had no idea. I didn't know, when I'm involved with this stuff, 80% of our prescription drugs were coming in from other countries. And so we really lost control of our whole manufacturing process. And one of the things that Shell Crescent USA did, we couldn't, most of our leads and prospects to bring, and all we do is promote the region. Once we get a company to buy into the fact that they need to come to this region, then the individual states suddenly take over and they work. We never leave them alone. We're always there with, matter of fact, just before this call started, a gentleman called me that we're working with, and they're going to actually locate in Washington County, Ohio. That's great. We don't care what state they're in, as long as they come to the region, because that's a win for all of us. And I guarantee you, some of the people that are going to work at his facility up there are going to be living in the Parkersburg area. So that's good news for all of us as West Virginians. But we couldn't, most of our leads come from conferences. We couldn't go to conferences. So we started doing media, and we did, folks, probably 70 plus radio shows. And what we learned, you can flip it, Maribeth, we learned is people around the country suddenly realized that we were dependent on places like China. We had assembly lines that were shut down because of the pandemic, but it wasn't because the employees were sick. It was because there was a piece in that assembly line that was coming from China or even Europe and couldn't get here. So we were shutting assembly lines down because we were dealing with global supply chains. Well, we know what global supply chains, how fragile they can be now. We had a ship stuck in the Suez Canal. That impacted us in this country. So we had a freeze in Texas, and all of a sudden, the producers here, we have 70% of the polyethylene and polypropylene. That's those liquids that Maribeth's company produces. People that turn those liquids into stuff, 70% of those are here. But what we didn't have here are the people that turn those things in, those liquids, into pellets. So what's going on today, we've got those natural gas liquids that are being produced in Sherwood. They're being shipped to the Gulf Coast or being shipped to Europe, and they go into what they call an ethane cracker, and they're turned into a pellet. Well, guess where those pellets come? The ones that are on the Gulf Coast are being shipped right back here. So our message is, let's start, and we have, we'll talk about that later in the program, but here's the thing. Americans want manufacturing to come back here. They want the jobs, but they want the stuff to come back here too. Go ahead, flip the slide to the next one. And so our message to plastics processors is, come here, because this is the only place we can think of, folks, on planet Earth where a company can build on top of the feedstock, literally. The gas and the liquids are under their plant, like Shell's got that ethane cracker up in Monaca, PA. Literally, their feedstock is coming from 50 miles away. So you can build on top of the feedstock and in the middle of your customers, because 70% of the people that are going to use that polyethylene and polypropylene are already here making stuff. And where they sell that stuff, they're selling it here. We're within a day's drive of 50% of the population in the US and Canada, and we're in the middle of the world's largest economy. So that's what we're telling plastics processors, manufacturers, that it's more reliable, more profitable, and more sustainable. I'll talk about that in a little bit. Next slide, please. And here's the market. I mean, this is real numbers, folks. Today, annually, we're getting $500 billion worth of products from China. Now, my message to manufacturers is look at what we're getting from China. And if you can make that, you can probably make it here cheaper. And here's what's already happening. And I'm go ahead and flip to the next slide. These are just plastic imports alone. Almost every product has got plastics, and even a solar panel requires, you can't have a solar panel without natural gas liquids. I mean, that's really a fracking product. So unfortunately, most of our solar panels are made in China. So it's time to start bringing that manufacturing back here. But this is just for people that make products 100% plastic. That's $45 billion. That's a huge market that we're telling manufacturers that you can have that. And we can talk about why that is, but that's huge. Go ahead, flip to the next one. And just to give you an idea, and 60% of those imports come from Asia. And we talk about plastics. People think about plastic bags, but medical equipment, you go to the doctor's office, look around, most of those products are plastic. My wife's knee is made, actually, it's made at a plant in Ohio. It's plastic. If you have a knee replacement, if you have a joint replacement, and I've got a crown in my mouth, and I asked the dentist last summer, I said, there isn't any chance this thing was going to be made in China, and he starts laughing. It was a nervous laugh. And he said, no, he said, we're getting them from China. They were made out of gold and ceramic, and we caught the Chinese substituting nickel for gold because it was cheaper. And nickel isn't exactly the best thing to have in your mouth. And he said, so now we're making them out of ceramic and zirconium on a 3D printer here in the United States. Again, those are US jobs. But he said, that crown you've got in your mouth, Greg, it won't chip, it won't crack. And so so how do we get here? Good. And here's what's happening, and a really neat correlation here. If you look at the gray bars, that's manufacturing jobs. And you can see starting post-World War II, we've saw an increase in manufacturing in the United States, that whole post-World War II boom. And the peak was in the 70s, around 19 million jobs is what we had in this country. The other thing you'll see is that blue line is oil and gas production. And there's a direct correlation we see between manufacturing jobs and oil and gas production. And in the 70s, I think most of the people on this call might probably remember the Arab oil embargo. But suddenly we got hit between the eyes with, oh my God, we're not in control of our own destiny when it comes to even gasoline. As our oil and gas production declined, because we were struggling, we had the oil energy crisis. As we lost that energy, we also lost manufacturing jobs. And then all of a sudden, Asia could do things cheaper. They were both getting our energy from the Middle East, but all of a sudden, China joins the World Trade Association in 2001, and all of a sudden, their manufacturing takes off, and ours goes on a steep decline until about 2010-ish. And suddenly the shale revolution, go ahead and flip that let's leave it. We'll leave it there for a second, because now all of a sudden, to what John and Maribeth have been talking about, we're seeing an increase in natural gas production. And along with that, we've added 1.4 million jobs. So go to the next one. And that's really what happened. It was a shale revolution. It was our ability to drill horizontally. And that's a great slide right there. It's our ability to drill horizontally and fracture horizontally. In the United States, right now is the leading oil and gas producer on the planet. And what most people didn't know, we were at the Shell Crescent was at the World Petrochemical Conference in 2017. And Wally Candle, Senior VP of Solvay, comes up to us, and he was in one of these executive meetings. And he says, Greg, he says, they have no idea. They think all the gas is coming from Texas. And 85% of the new natural gas production isn't coming from Texas. It's coming from here. This region, these 3 states, and flip the next slide. And this is how dramatic it is. The USA is number 1 oil and gas producer in the world. Russia's number 2. Number 3 is Shell Crescent USA, our region without the rest of the USA. That's not, the rest of the USA outside of our region, Russia 2, we're number 3. and look what everybody else is behind us. We have this massive production of natural gas and natural gas liquids. Go ahead, flip the slide again. And what's really important is this region produces twice as much gas as the entire nation of China. So start to think about what that means. And that's, and you look at the growth. When we look at going forward, future supply, the rest of the US is pretty flat. This region is where the growth is. So our message is, look, if this is where the gas is, and this is where the liquids are, this is the most profitable place to locate manufacturing. And that's huge, because what we're seeing right now is those liquids are leaving the country. Some are going to Canada, some are going to Europe, some are going to the Gulf Coast. And that's huge that we're beginning to produce those here. And the other thing, it's changed. So now we know we have energy, but we're seeing an increase in labor costs in China. Go ahead, flip to the next slide. And this is Boston Consulting Group put this out. And to give you an idea, if you took manufacturing cost, this is without energy, US is 100. We're using that as a base. Look at where we are compared to China. We're basically on a par with China, on a par. Vietnam is a little cheaper than China. We're on the same realm as South Korea. Europe, their manufacturing costs are significantly higher in Germany and places like France. But suddenly the labor advantage that China had no longer exists. Their wages have gone up, and we have something, and Marshall's involved with this, advanced manufacturing, robotics, our ability to manufacture. We don't need as many folks, but what we do need is we need to educate the people we have. Our students need to know that these aren't grandpa's manufacturing jobs. They're not even your dad's manufacturing jobs. These are high-tech, modern jobs that we need. These are technical jobs. My students work in shorts and a golf shirt. I mean, they're working inside, but they're trained. They've got to be trained. Next slide, please. And this is the other thing that's changed. Shell figured this out. And what we're looking at is we're beginning all these natural gas liquids. We're going to places like the Gulf Coast, and their ethane crackers turned them into polyethylene pellets, and they're shipping them back here. Starting in 2022, Shell is going to be producing those pellets. They're going to be using Appalachian natural gas and natural gas liquids to produce polyethylene pellets right there in Monaca. And here's what that means. And even the processors, the people that take those pellets and they'll turn them into products anywhere from, you know, a cell phone case to fabric to medical equipment. And all those things are going to be supplied. Now we can start supplying those with Appalachian gas, Appalachian pellets. And here's what it means. Right today, those pellets are made in the Gulf Coast and they're shipped back here. Now, we've already had hurricanes. We've already had that freeze was dramatic. What you may not realize is that 80% of our polyethylene production, those pellets, when they lost their power. When they lost power, a lot of they didn't just lose electricity, they lost natural gas because some of their compression stations were run by electricity. Long story short, that whole Texas freeze put 80% of our polyethylene production down for weeks at a time. Right now, I do a lot of conferences. They're about 50% back, and it's growing. But right now, what that means is these people up here that are making products, A, they're paying more for their polyethylene pellets, and B, some of them can't even get them. So if you're making even PVC pipe, you're having trouble getting things. And what that means for you and I is we're going to be paying more for the milk jug and everything else. So that's why, and it's real important. We're still getting 60% of the stuff from Asia. It's time to start making that here. And we're looking at not just Shell, PTT's looking at it, and we're actually talking to other companies who want to come here and build crackers. So this is huge. This is a big deal. And we're already starting to figure this stuff out. I was in a drugstore the other day, my local pharmacy, and I had some a couple generic or a couple name brand drugs, and I went by the generic counter, and I thought, well, I'll look, but you know, I know where those things are made. They're all made in China. And I looked over, and the generics are made in the USA. And I'm thinking, this product was made under the FDA guidance, and it's cheaper than my name brand. I looked at the name brand. The two name brands I had were both made overseas. Guess what I did? I put the name brands back, bought the US generic. It's made here. It's basically the same stuff, and it works the same as the name brand. The only difference is When it's made here in the US, we're talking about US jobs, US workers that pay taxes. And it does something else for us. Go ahead, flip the next one. Because that's where the real message is. Manufacturers, if we look at regional supply chains where everything's contained here within the region, better profitability because you've lowered Shell. If you're buying pellets from Shell, you're getting those literally. They told us, if you call us on Monday, we can have pellets to you by Wednesday. If you're getting those same pellets from the Gulf Coast, you're getting them by rail. I was talking to a processor and I said, what will Shell mean to you? And he didn't really grasp what was going on. I said, well, Bob, tell me something. If you could get your pellets in 2 days, what would that mean? He says, because there, you see those 5 silos? He said, those are all full of pellets that I'm getting from the Gulf Coast. And he said, that doesn't count what I got riding the rails between here and the Gulf Coast. He said, I don't need those silos. And all of a sudden, can you imagine how many millions of dollars he got tied up in inventory that he doesn't need if he's getting it from Shell? Next slide.
We got about 5 minutes here, Greg.
Perfect. Oh, that's you've nailed it. I'm right at the end. That's beautiful. Here's the big thing on what we looked at on sustainability. And right now, I'll just use China for an example. We know where they are with energy. They don't have the energy resources that the United States has. So they're getting to make their pellets, polyethylene pellets, they got to come from the Middle East, primarily Iran, but they're getting it from OPEC. That's a 7,000-mile journey on a ship. And those ships don't exactly burn the cleanest fuel. A huge carbon footprint to take that oil from the Middle East to China. And then they're going to turn it into a pellet under their environmental law. And they're going to ship that. They're going to turn that pellet into a product. And then they're going to ship that product literally halfway around the world to the West Coast. And then from the West Coast, they're going to ship it all the way to us. Huge carbon footprint. And our numbers for those things, we're looking at 50 to 75%. And just, we're doing a study of the things that should be made here and can be made here cheaper than we can make them overseas. And when you look at those numbers, folks, it is dramatic. The carbon footprint that we can eliminate just by manufacturing something right here, that just say in our region, using our energy, our feedstock, you make the product here, you're providing US jobs, and the consumers here are buying it cheaper, just like I did those generic drugs. They can make those generics a whole lot cheaper here than they can in Asia because we've got the energy, we have the manufacturing know-how, we have advanced manufacturing, and we're talking about shipping the energy basically under the plant. And you're talking about trucking it a few hundred miles instead of bringing it halfway around the world. So that's really, when we start looking at sustainability, this is the way we're talking about dramatic increases in sustainability, reduction, carbon footprint. So this is what we look at is here's the opportunity to bring manufacturing back to create. I got 3 kids. None of them live in West Virginia. They would love to live here. And we have that opportunity now. And education is going to be a big part of that because these aren't labor jobs. These are high-tech jobs. We're going to need, and we've been working with the labor unions. We need skilled tradespeople. So manufacturers, engineers, all those jobs are going to be really important. But we have this, we call it a generational opportunity. So really, I think that hopefully that kind of summarizes a little bit of where we are. But
That's a great overview. You've been doing great work on this question. You know, when we started producing back in 2008, we're aware of how prolific these wells were and how much ethane and propane, you know, and knowing that leads to ethylene and polyethylene and, you know, carpets and wallpaper and everything else. We've just had a hard time getting our hands around that. And I know Shell Crescent has done such a great job. And the cracker in Monaca, but that's 3 miles from the West Virginia line up there.
Absolutely. And you know, what's really, my wife's a nurse, and that whole PPE, we couldn't get healthcare PPE. And to be able to take control of that, we're working with a company that's going to make gloves in West Virginia. So when we can make our own hand sanitizer, and we had companies, good friend of mine in Jackson County, pivoted and he was making construction products and suddenly started making ventilator parts. So
Yeah.
we can do that. We can start creating more jobs and have control of our own destiny when it comes to PPE and really the products that we need and use every day.
Well, Elizabeth, that's what we've got for you.
I have a quick question. This was actually very fascinating for me. Will natural gas still be around? I know, and I don't want to get into a political discussion at all, but I know that there are those that think that we don't need natural gas, that we need other means of energy.
Well,
And I'm about to invest in a natural gas run generator. Because we went 8 days without power. We're over it.
I can relate to that.
I'll speak for myself. I know that I believe a transition to low carbon future is coming. I mean, I have to see that happening. But I also believe that natural gas is part of that. Let me share my screen one more time to talk about how, natural gas is methane is CH4. So it's one carbon atom. And because the power sector, because of, some of the EPA administration decisions, power generation is moving now to more natural gas than coal. And it has led to a big decrease in carbon emissions. And I'm going to pull up,
Maribeth, can I add one thing that may help too? Is we always think of these natural gas as fuel, but when we look at renewables, the challenge here that a lot of people don't grasp is renewables make electricity. Our products, my shirt, the cell phone case, require molecules. And we need natural gas and natural gas liquids to provide the molecules to make solar panels. You can't even have an electric car without fracking. So that's, we really need the molecules. So that's one thing moving forward that right now, that's the solution. I mean, we got to have those molecules no matter what.
So you look at carbon emissions from coal consumption decreased by 28%, 28%. Largely attributed to natural gas to generate electricity. And when we talked earlier about LNG, liquefied natural gas, it's funny, you hear NGLs, which are natural gas liquids, propane, et cetera, and LNG, which is liquefied natural gas. We are shipping liquefied natural gas, my company is, to India and other countries where they use it for power generation. So, you keep hearing about what America can do to get a handle on emissions, but it's not helpful if the rest of the world keeps burning coal. But when we send them LNG, they are able to grow and develop economically without all the emissions. It's that decoupling of growth and emissions that's been important. That's just a quick answer. We could spend a lot of time on that.
I know. So at least for the foreseeable future, our investment in our whole house generator will be
right.
Because the power grid where I live is so poor. I guess trees. We have trees everywhere.
Yeah.
And the trees brought the lines down.
Yeah. And you have to have natural gas to back up wind and solar. The natural gas turbines fire up and down more quickly. So when the wind doesn't blow and the sun doesn't shine, natural gas is the natural coupling for wind and solar. That's
what happened in Texas. The turbine, the wind, what am I trying to say? The energy run by wind couldn't run. Yeah, there were problems. There were problems across all kinds of sectors, and the grid just needs to be updated. It seems. Oh, absolutely. Yeah, that's a whole nother conversation. Everything. Right. So, well, thank you for all of you for this was just really, really informative. Way more in depth than I thought it would be. Not that I didn't think it would be in depth, but I'm like, wow. Me too. I got to figure out what John meant when he said North is not the same as it was 25 years ago. You mean North is not the same now, but I'm sure he's right. I did not know that. I did not know all that about the magnometer and the magnetics and all that stuff. So, right. So this was, thank you for your time and all the effort you put into this. And I'm just thankful for Zoom that the one gentleman was from Colorado, correct? Right. Yeah. So thank you. You put a lot of time and effort into this. And Is there any way to share any of your slides with me via email?
I will send them to you. I'll have to look. I need to get approval, but I
You're
will.
Well,
welcome.
if there's
You're
anything you can
Maribeth, you're welcome
share,
to
I'll
share
send it
our
out to.
slides, Shell Crescent slides.
Okay, I'll send the Shell Crescent slides.
Yeah,
Absolutely.
if you, anything you can share, then I'll send it out to the group, and, because it was just it was fascinating.